The notes that I'm about to go over come from your binder. We are skipping literal equations for now, solving literal equations for now, and moving on to interval notation and solving inequalities. So starting on page 4, we'll run through the notes here. For interval notation, if you got through the delta math, you'll probably understand exactly what it is that I'm going through here. So for interval notation, it's important that we understand that the symbols in an inequality could be the less than symbol or the greater than symbol. When we're graphing using these two symbols, we will use an open circle above the number, and then there's an arrow that's pointing either to the left or to the right. And then the interval notation, when you have just less than or just greater than, is using parentheses. So when we use the parentheses, it's important to know that the interval contains two numbers. So it could be like one parentheses or the other symbol, which we'll go over here in a second, which are brackets. And so we use the brackets when we have less than or equal to or greater than or equal to, and the graph will have a closed or filled in circle above the number. For your inequality signs, here's an example of what all of those look like. So reminder here, this would be x is greater than 3. And so when I go to graph this, I go to the number. So I go to 3. It'll be an open circle, and the arrow points towards numbers that are greater than 3, and those numbers would be found to the right. Next, we have x is greater than or equal to 3. So again, greater than or equal. And so the only thing that's different from this one compared to the first one there is that now above 3 we have a closed circle showing that 3 is part of the answer, and then the arrow still points towards the larger values. The last two we have less than and less than or equal to. So for the one here on the left where we have x is less than -2, so I go to -2, it's an open circle, and it points to values that would be less than, which would be numbers to the left. And then for this last one, because it's less than or equal to, the circle is filled in, and the arrow is still pointing to the left. So open circles for just less than or just greater than, closed circles for either of the or equal to pieces. Moving along, given the graph, we're going to write the inequalities and use the interval notation. So for writing the inequalities on this first one, what I'm looking at is I'm first going to just state like x. That's how we're going to start all of these. X is less than, x is greater than, whatever it may be. So when I look at this graph, I see that the number I have here is 4. So it'll be x something with 4. And the arrow is pointing towards numbers that are greater than 4. So x will be greater than 4. I know it's not going to be equal to because that is an open circle. So the one to the right, for just the inequality here, I'm going to be comparing x to the number 5, and the arrow is pointing to numbers that are less than 5, and since the 5 is filled in, I put the little bar underneath for the or equal to piece. So x is less than or equal to 5. On the next one, I'm comparing x to -1. The arrows, sorry, are pointing towards numbers that are bigger, so x will be greater with no bar underneath. And then the last one, this will be x is less than or equal to, and we'll just call that 6.5. Now for intervals. So for intervals, we state a list. It kind of looks like a list. And it's going to be two values separated by a comma. And so what you write are the left side and the right side of the solution set. So like for this one here in top left, this interval starts at 4, and then I put a comma. Then it ends on the arrow. And so, well, what's that arrow pointing to? It's pointing towards infinity. So my two values are 4 and infinity, and then every interval has to start and end with a parentheses or a bracket. So since the circle is open, And since there is no line underneath my greater than symbol, this would be a parentheses. Infinities always get parentheses. So just a reminder, open circle will be parentheses. A closed circle will have brackets, but infinity is always, always, always a parentheses. So now moving on to this next one. So I still read the graph, always read left to right though, you guys. So here, starting on the left, that's an arrow. So that arrow is pointing at negative infinity. It ends at 5. So because we have a closed circle, 5 gets a bracket, but your infinity will always have a parentheses. On the bottom left, interval starts at -1, ends on the arrow. So that's -1 to infinity, -1 gets a parentheses, infinity gets a parentheses. And on the last one, start with the arrow, so that's pointing at negative infinity, ends at 6.5. It's a closed circle, 6.5 gets a bracket, infinity gets parentheses. Now for solving. So if you made your way through Delta Math, you probably understand how to do this. So when we solve inequalities, it's very similar to equations. Just make sure you maintain the symbol. So on this first one, we have x plus 9 is less than 15. So I still subtract 9. I get x is less than 6. So that would be the inequality solution. The interval, I'll write the interval after I draw the graph here. So I'm going to go to 6. I have an open circle, and then it needs to point towards the x's that would be smaller, which would be to the left. So now when I write the interval, I'm looking at the two ends of the graph. So there's the arrow, there's the open circle, and that tells me what I need to write the interval. So this starts at negative infinity, it ends at 6. There'll be a parentheses on the 6 and a parentheses on the infinity. On this next example, we'll add 3. We get x is greater than or equal to -3. For the graph, I would have a closed circle at -3. X's that are bigger would be found to the right, so there's the graph. And then the interval notation would be -3 to infinity, bracket on -3, parentheses on infinity. Next up, here we would just have to divide by 3. We get x is less than or equal to -7. So when I graph, I go to -7, closed circle, pointing to the left, and the interval would be negative infinity to -7. On the next one, so this is supposed to be x over 2. I'd multiply both sides by 2. I get x is less than -6. That's an open circle at -6 with an arrow pointing to the left. And that interval would be negative infinity to -6. Now, when we get to these last two, something interesting happens that I haven't had to mention before. When you multiply or divide by a negative number, you have to flip the inequality symbol. So, multiply or divide by a negative, flip the symbol. So here when I divide by -8, I would get x is less than -5. So notice the symbol switched. So that's the solution then for the inequality. When I graph this, it would be an open circle at -5, and then x would point to the left, and the interval notation would be negative infinity to -5 with a parentheses. On the next one, I'm going to multiply both sides by -4. So since I multiplied by a negative, the sign's going to flip, and it flips on this very next step. So this becomes less than or equal to positive 8. So I go to 8, close circle, and the arrow points to the left. And our interval would be negative infinity to 8 with a bracket. All right, so here on page 6, this is just kind of the same thing, just the reminder when you multiply or divide by a negative number, flip the sign. So here on these examples, here we'll add 7. 4x is greater than 12. Divide by 4. X is greater than 3. So here's 3, open circle, arrow points to the right, and that interval would be 3 to infinity with parentheses. Next up, subtract 2 from both sides. We get negative 2x is less than or equal to negative 20. Then I'll divide by negative 2. So I just noticed that I'm dividing by a negative. So on this very next step, the symbol has flipped. So notice, was less than, now it's greater than. So that graph will be a closed circle at 10, with the arrow pointing to the right, and that interval is 10 with a bracket to infinity. Now for the last 3, just multiple steps here. So on this one, again, treat the symbol as like an equal sign that can help you figure out where it is that you need to take the problem. So here we're going to distribute first. So that's 12x minus 36 plus 2x is greater than 6. Now I'm going to combine like terms. So 12x and 2x is 14x. So 14x minus 36 is greater than 6. Then I will add 36. And I get 14x is greater than 42. Divide by 14, and x is greater than 3. So that's the inequality solution. I got a lot going on here, so let's change some colors. So we can go to 3. We'll have an open circle. X is greater, so it will point to the right, and that interval would be 3 to infinity with parentheses everywhere. For these last 2, I'll just solve them. I won't say very much here. So notice on this one I divided by a negative, so I did flip that symbol. So then on the graph we would have an open circle at negative 5, an arrow to the right, and the interval would be negative 5 to infinity. And here for the last one. On this one, we do have x's on both sides, so treat it just like you would an equation. Typically, we like those x's to be on the left, especially for inequalities. So this will be 8 minus 9x is less than or equal to negative 10. And then this is a positive 8, so to move it, I'll have to subtract 8. That will give me negative 9x is less than or equal to negative 18. I'm dividing by a negative, so the symbol is going to flip, and x will be greater than or equal to 2. So I go to 2, it's a closed circle, the arrow points to the right, and as an interval, that's 2 with a bracket to infinity.